So good morning all. Welcome to Sai Embedded Automotive. So today we are going to discuss about the CAN protocol. So why CAN protocol is needed? What is a protocol actually? So we have many protocols available in the automotive industry like SPI, UART and I2C. So why we are looking for the CAN protocol? So what is the reason? So basically coming to the CAN protocol or CAN bus. So CAN is a sophisticated protocol and it is having the feature called error handling and error correction. So among these three protocols like UART, SPA and I2C, that protocols is having only the onboard communication. So if you see, onboard communication means within the board only we can communicate with the other components like other slaves or electronic devices. So similar way, if we see CAN protocol bus, so it is having the two wires features. So it will reduce the wiring harness. First, the basic thing is it will reduce the wiring harness and it will gives the more efficient data to the respective node. So basically CAN is a controller area network. Okay, so CAN stands for the controller area network, or that is a microcontroller area network. So so what is a bus? A bus is a channel of a communication between two or more electronic devices, like where messages in the form of electrical wave from can travels in the both direction. So when it will travels in the both direction, in the sense like either a receiving or a transmitting. So that is the meaning regarding the both directions. Okay, next. So just will go. So where this what is the futures and what is the applications of the CAN bus means, in CAN bus we can use in the automotive, aerospace, medical and lifts, factory automation and some other applications we can use, mostly widely used in the automotive sector. Next, what are the features of the CAN means? CAN is a broadcast announce message, means CAN is a message based protocol, not a address based protocol. So it will having the two wire communication. One is CAN high and another one is CAN low uh, wire, means there is no limit number of nodes we can connect, like up to, as per the current we can connect up to 40 to 45, like in the modern cars we can connect up to 40 to 45 nodes of the ECUs. Okay, and we have already we discussed, like it is having the great feature called error detection and error handling, and it will supports the speed up to 1 mbps, and it is having the great reliability on the message transmission, so there is no collisions between the messages will happen. So as a protocol instructions, it will pass the messages smoothly, and we have two versions of a CAN it is available. So one is CAN 2.0, that is standard frame, and CAN 2.0b0, that is extended frame. So what which ISO CAN will follows? CAN will follows ISO 11898-1. So that is the international organization standards, so it will follow that ISO. Next, why do we need a CAN bus? So this is a one important question it will raise from the interviewers also. Well, so without a CAN bus, the point to point communication will be happen in the previous protocols. So now if you see, the controller A is connected to the controller B, from the controller B it is directly connected to the controller E and controller C, D, E, F, G. So in that case, which wiring harness is connecting to the which microcontroller, we unable to found the issues. So to avoid this kind of point to point communication, so CAN bus came into the picture. If you see how this communication is happening with easily understandable, like which bus is connected to which microcontroller. If you see here, the green line is a CAN low and above upline violet color is a CAN high bus. If you see the controller, see controller we call it as a electronic controller, means electronic control unit or a vehicle control unit, and BCM, body control unit. So we have different types of microcontrollers are available based on the vehicle. So for example, if I am dealing with engine control, so if I am working with engine control ECU, so we call it as a engine control ECU or a powertrain ECU. If controller E is working on the body control ECU, means body control ECU means what is like of cockpit and wiper and other some features related to the seats and instrumental cluster, everything will comes from the body control ECU. Next, VCU means vehicle control ECU, means what it's exactly. So it will control the vehicle like speed and brake, act pedal, gear and cruise control, hill hold assist switch. So these will be comes under the vehicle control unit. Next, example for the CAN bus with 8 nodes. If you see here, so the orange color highlighted things will be having the features like it is connected in the ECU with wiring harness. Okay, means 2 wires only we use. So we'll go like from where we have introduced this CAN. So we just come to know like who introduced the CAN. So CAN was firstly developed by the Robert Bosch in the year of 1986 when they are requested to develop the communication system between the 3 ECU like electronic control ECUs in a vehicle designed by the Mercedes. They found that point-to-point communication was no longer suitable in the situation. The need for the multi-master communication system become the imperative. So the first CAN silicon was fabricated in 1987 by Intel. Coming to the advantages of the CAN, so it is well organized and sophisticated compared to current point-to-point communication, and it will reduce the weight and cost of wiring harness. CAN handles like multiple controllers simultaneously and it will works in real time, can be used various applications. So CAN bus system works by sending the receiving message from node X to node Y. So what is a node? A node is a sensor or actuator connected to the microcontroller and any other devices like ADC sensor. It will helps to convert the assembly to the fully functional standalone unit is called the node. What is standalone unit? Standalone unit is a one kind of application, so it will be used in particular ECU only, means we cannot use in the multiple ECUs. So there are two types of nodes. One is transmitting node, another one is receiver node. So in generally transmitter node we call it as the TX messages and receiving node we call it as the RX messages. In generally, a node is a originating a message is called a transmitter of that message. Coming to the receiver, a node receives a message that it's not transmitting itself is called the receiver of a message. Next, nodes send and receive the message by obeying the highly sophisticated protocol and set of rules called the CAN bus protocol. Next, how many CAN bus protocols are there? So we have CAN 2.0, it is a standard frame, and CAN 2.0b, it is an extended frame. In 2.0, a user with smaller amount of data we can transmit, and 2.0b, it is a user for larger and more complicated. Next, CAN bus is a message oriented protocol. It is not an addressed. Okay, we have two types of messages will be there. One is standard message ID and another one is extended message ID. So standard message ID consists of 11-bit message identifier and extended message identifier consists of the 29-bit message identifier. Okay, so there are only two frames are available, means a frame that consists a request for the data, a frame consists of the requested data. We can see that is in the upcoming slides. So the frame that contains a request for the particular data is called the remote transmission request frame. We call it as a RTR frame. So remote transmission request frame. And the frame that contains the requested data is called data frame. So what is data frame here? If you see, this is a CAN standard frame. So first it will start from the bus idle. What is bus idle? Bus idle, whenever if you turn on the ignition, so bus will be in the idle state, and it is a startup frame. Startup frame, it will represents the enabling the frame. Next, another field is arbitration field. Next one is a control field, data field, CRC field, acknowledgement field, end of the frame, and intermission frame. Startup frame consists of the 1 bit. Arbitration consists of the 12 or 32 bit based on the standard or extended frame, and control bit consists of the 6 bits, and data field consists of 0 to 8 bytes, and CRC field consists of the 16 bit, and acknowledgement field consists of the 2 bits, and end of the frame consists of the 7 bits, and intermission frame consists of the 3 bits. Next, coming to the RTR frame, remote transmission request. So it is also similar from the startup frame to till intermission frame. So in the remote request frame, we don't have seen the data field because we are requesting for the data. So in that case, we don't have the data field in the RTR frame. So one of the most important thing we should understand, a frame consists of the large number of bits, that is zeros and ones. So the bits represent in the frame are two types. 0 represents the dominant bit and 1 represents a recessive bit. This is the most important thing to understand. 0 represents the dominant bit and 1 represents the recessive. So it will communicate either a dominant or a recessive bit. So we have dominant is having the highest priority than recessive bit. Why? What is the reason behind that? Because the CAN follows the wire AND logic. So in the AND logic, if you see the highest priority will be the zeros only. Okay, so that's the reason it will follows the dominant is having the highest priority than the recessive bit. So shall we discuss like 7 parts, like making the frame starting from the start of frame to till end of the frame. Startup frame consists of a single bit. This is the MSB, most significant bit present in the frame. So it is always 0. Next, arbitration field. The arbitration field is the most important field for the programmer or the system designer. It is also called as the identifier field, as the identity of the entire frame traveling on the bus figure out the decoding this field. So what is arbitration? If anyone will ask question, what is arbitration field? So the settling of the dispute between the two or more individual by the third person chosen. In the CAN, so the translate into the settling of the collision between two or more frame sent on to the bus simultaneously by two or more nodes with the help of the CAN protocol is a third person. Means, for example, if I am having 0x71A, 0x72B, 0x73B. So in that case, how it will win the arbitration means based on the lowest message ID is having the highest priority, as we discussed, right? So CAN is having the dominant is having the highest priority. So if you see 71A, 72B, 73B, so one is having the low, so compared to the third one. This is not required. Yeah, we'll go with the arbitration and what fields contains. So here if we discuss 2.0 version consists of the 11 bit, so we can send up to 2048 different combination. How this 2048 came into the picture? So 2 to the power of 11, if you calculate, you will get this answer. Okay, and just I drawn here. So since the flow between the binary format consists of zeros and 1, 11 bit can gives up to 2048 combination as follows: 2 to the power 2 into 2 4 4 to the 8 8 to the 16 16 to the 32 32 to the 64 64 to the 128 128 to the 248 248. So like that you will get this 2048. And can 2.0b consist of the extended frame? What is extended frame? Extended frame is used for the heavy duty commercial vehicles, and if we try to send the more data, so we can use the 29-bit message identifier. This means that with the 29-bit along the identifier, there are be 5 million unique frames will be configured. Okay. Next. Coming to the control field, it contains a 6 bits. The first bit is an IDE. What is IDE? Identifier extension bit. This bit is used if the CAN bus 2.0b is with the extended identifier. So then it will be it contains the 29-bit desert to be used. The second bit is a R0, has been reserved for the future use if the status is having. Next, control field. This last 4 bit represents the number of bytes that to be present in the next field, the data field. There can be a maximum 0 to up to 8 bytes of data we can send in the CAN bus. So only 8 bytes of data we can send in the CAN. Yes, we can send only 8 bytes of information to the CAN bus. So if we want to send more than 8 bytes of data, then we can go with the CAN-TP protocol. So that video I will present you like in the further slides. So about the CAN transport protocol, CAN FD, how this data will transfer into the more number of bytes into the ECU. So that I will make one session on that. Next, if you see this data length, so this how it will be set as 0 consists of in the binary 001, and 1 represents 001 and 2 0010. This will be follows the 8421 code. I think everyone knows about this code, so based on this the calculation will be happen. Next, coming to the data field. Data field consists of the data, how we can send the data to the CAN bus. We can send up to 0 to 8 bytes. 8 bytes of information we can send. If we consist of 0, then it will be the 0 to 7 bytes. If we start with the byte 1, then it will be the 8 bytes. We can convert into the bits, means 64 bits we can send. Next, the most important questions will rise from the interviewer. CRC, cyclic redundancy check. This field is used to calculate the bit error present within a CAN. The controller doesn't does this operation automatically. So there are the total 16 bits present in this field. So the value bits, the first 15 bits fields are automatically calculated. The last bit called as the CRC delimiter. It is always recessive. Coming to the acknowledgement field. So acknowledgement, why this acknowledgement field is important in the CAN bus? Why the other UART and SPI doesn't have this acknowledgement field? Because acknowledgement field, the most important field whenever we are sending some 8 bytes of data to one microcontroller. So whether that data was received successfully or not, this acknowledgement field will gives the correct information. Data was successfully received or not. The acknowledgement delimiter is a case where all delimiter found in the recessive, and the node transmitter frame transmit the acknowledge slot as a one recessive. Next, end of the frame. So end of the frame consists of the 7 bits. So it says the frame ends. Next, coming to the intermission frame. So the intermission field consists of the 3 bits. All these bits are recessive, and the intermission field is present between the consecutive data frame and RTR frame. Next, so the part 2 we can go with what is types of fields are there, what are the types of errors we have in the CAN bus, and what is the error state flow diagram in the CAN.